the opportunity. My name is Andy Grabner. Andreas is the full first name, but please call me Andy if you see me somewhere around. I'm a CNCF ambassador, very proud that I've been elected to that role. So a Cloud Native Computing Foundation ambassador. I'm also a DevRel for the CNCF project Keptn, which you will see today. I have a lot of stuff prepared, and I'm also the global DevRel lead at Dynatrace. Dynatrace is a software intelligence company in the observability space, and we are providing answers to the data that we collect. But today the focus is really around measuring the success of IDPs with OpenTelemetry, DORA and SLOs, as it was said. You have all the links here, but let's get started because we do have a lot of content and we have hopefully questions that we can answer later. First of all, you will see a lot of live demos later from me. Hopefully you're excited about this and you don't shy away of seeing YAML and the terminal window and some graphs and traces and much more. The live demo that I'm doing, it's been a live demo that I've been building over the years. It is also accessible on this public GitHub repository. So it's going to contain a KLT, that's Keptn Lifecycle Toolkit, on K3s, a lightweight Kubernetes cluster with Argo, with Prometheus, with OpenTelemetry, with Jaeger, with an integration to Slack for notifications. So it's kind of like a little platform package that obviously doesn't contain all of the components you would normally put into a platform, but some that give us the ability to get the observability we need to measure the success of an IDP. Now, the URL, sure, I think maybe Maria, if you're still there, there's a question on also posting the URL. I will, if I don't forget, once I'm later in the browser, I will share it. But if you can do me the favor, maybe just post it in. The URL should be easy to grab. Okay, cool, awesome, perfect. Let's get started though. And what I want to do is, and again, I need your help, Maria. Again, we have a quick poll because I would like to get a little bit of an idea on whether you are familiar with these topics. So I think there's going to be a poll coming up, I assume on Zoom. Poll number 1.
It is on. Yes.
It's on, exactly. Are you familiar with the following terms and technologies? OpenTelemetry, DORA, SLOs, GitOps, and Keptn. So it would be great if you can do me the favor and just go through this. And while this is happening, what I'm doing on the side here, I am going to also give you the link to that repository that I mentioned. So I think we'll keep maybe the poll open for a minute or two, or like a minute maybe. You tell me how long until we have enough answers. And here we go. This is the, actually I'll post it to everyone. Here is a link now to the GitHub repository with the demo, just to FYI.
I see some people having troubles copying the link, but I'll take a look into that. Maybe just click on it and then like copy it from your browser. Sorry about that. But yeah, the poll is multi-choice, so you guys can select different answers. And I think we are done. At least I don't see I don't see many answers coming in now. So I'll end the poll and you can see the result.
Yeah. Thank you so much. Oh, there's some good answers here. Okay, so no surprise, GitOps obviously 90%. That's great. OpenTelemetry 81. That's awesome. DORA 45. That's a little surprise. I thought there's more on that. SLOs is 65. That's great. And Keptn only 6. So obviously I have a duty today to make sure that more people are getting to know about Keptn, but the rest gives me good indication, especially as I move through my content. So quick introduction of the agenda. There's really 2 big pieces. First, a 3-minute introduction to these topics. I know most of you are familiar with it. Great. But quick introduction to OpenTelemetry, SLOs, and DORA. And then I have 3 demo areas. The first one is going to be to really measure the impact of change, like how often you deploy and whether it's successful. This is the DORA metric. The second one is around how can we make sure that pipelines or deployments that you do also validate all the tests that need to be done to make sure that your deployment is really successful. This is where the SLOs come in. So validating deployments based on SLOs, but doing it natively in Kubernetes instead of pipelines. And then another thing is from an observability perspective, we can also leverage observability data to do more in your platform, like enabling tools like HBA, CADA, or Argo rollouts, any tool that needs observability data to automatically scale or roll out or roll back things. How can we use this as well? And with this, make the success of your IDP, your internal development platform, a higher chance of success. So, quick introduction. First of all, I want to start with the fact platform engineering is taking off, and it's having Kubernetes as its core. Whether we can, attribute this to Kelsey Hightower, who said years ago, Kubernetes is a platform for building platforms. It's a better place to start. It's not the end game. He definitely had a big impact on the whole movement of Kubernetes. And what we're seeing right now, and this is from the annual survey of the...
Sorry to interrupt you. The screen sharing froze at the poll. So
I'm so sorry. Here we go.
Yeah.
All right.
Oh, you have slides. Look at this.
Yeah, we do have slides. Thank you so much for making me aware of this. I was just wondering. All right. So fact is, platform engineering is taking off. Kubernetes is its core. And what you see here is results from the latest CNCF annual survey. We see a huge increase, obviously, in application workloads being deployed on Kubernetes, which is the apps that you want to run, that you run your business. But what's also really interesting is that we saw a 211% increase in auxiliary workloads. These are all of the different tools that are being used when building your IDP. So great, we know this, right? Kubernetes is at the core. We're building platforms. Platform engineering is taking off. But the question is, how can you measure whether your platform that you're building is really successful? Now, there's different ways of measuring it, but 4 key metrics, the so-called DORA metrics, have been introduced a couple of years ago and also have been referenced again in the latest State of DevOps report that was actually focusing on platform engineering. The DORA metrics talk about efficiency and resiliency of the things that you're deploying, how often you deploy, how long it takes you to get a deployment out, what's the change failure rate, so how many deployments fail, and if something fails, how fast can you restore the service. So these are the DORA metrics. For those of you that have never heard about it, it really came out of a lot of research that was done, and you can read it up on the Accelerate, and you will also find the references to DORA in all of the different reports around DevOps. Now, the thing is, DORA is great, but we also need SLOs. Now, why do we need SLOs? SLOs, on the one side are used in production and made very famous by Google, defining service level objectives to make sure that you're staying within your objectives, your targets. There's also the concept of an error budget to make sure that you can make better decisions on whether or not you still have enough budget left to deploy now or not, or how much error you can allow yourself. But I want to also bring the SLOs in the context of deployments itself. So here's the thing. Most of you know Kubernetes. That means if you deploy a pod in Kubernetes, then hopefully at the end of the deployment, Kubernetes will tell you, hey, this payment service is running 2 instances, everything is fine. The problem with this is pod running does not mean that the app is actually healthy, because just because Kubernetes knows the pod is running doesn't mean your end users can access the website or can make the payment. And this is a big problem, right? Kubernetes is not aware of what is happening outside. And so what we are bringing in the discussion here is we need to look at SLOs, and we need to allow platform engineers and also the people that use your platform to define SLOs, service level objectives, to say what is really the definition of health of my app as a deployed individual components on Kubernetes. And this is where you can, you should define multiple objectives like response time. Everything that gets deployed should have a reasonable response time to the end user. Failure rate should be low. And also the system should in general be available. How we can measure availability is a different topic, but typically done through synthetic tests or through real user monitoring. The point is, what we should do is we should automatically evaluate SLOs after a deployment happened so that we know whether pod ready or pod running really means application healthy, because if that's not, we should act on it. We should either roll back or make sure that we notify the right people to really get everything running out there. So this is where SLOs comes in, service level objectives. Another thing is, how do we get to this data? How do we know response time? How do we get error rate? How do we know availability? We need to observe these things. And one of the things that I want to highlight here again is OpenTelemetry. OpenTelemetry is the de facto observability standard here to help. Why de facto? You can see for yourself from the graphs and from the predictions here that analysts even do, is that OpenTelemetry is here, it's growing, it's here to stay. And by 2025, 70% of new cloud native apps will adopt OpenTelemetry. OpenTelemetry, what it is, it's a set of standards. It's a set of vendor agnostic SDKs that developers can use to make their components, their services, their pods observable. And it really is a standard that creates standard distributed traces, metrics, and logs that can then be sent to your backend system of choice. Whether this is open source or commercial is then in the end up to you. But it's a standard way how we collect observability data. Now, the first kind of pillar of observability that OpenTelemetry standardized was distributed traces. And distributed traces, it's been around for a long time, but definitely got a lot of boost with OpenTelemetry. A distributed trace is able to follow a transaction, a business transaction, or a request to your system from the end user all the way to the backend. Like in this case, maybe somebody opens up a page on your website that makes a web request on the certain URL, demo all here, maybe then makes a call to the authorization layer if you're really allowed to get all this data, and maybe that web service, that pod is then making a database call to validate if you actually have the right to see all this data. And so what we get with OpenTelemetry, we're getting distributed traces that are including individual, we call them spans. So every bar here is basically a part of that end-to-end trace. And on every span, you have a lot of metadata. For instance, what is this type of request? Is it successful, failure, timings, and so on and so forth, which we can then use to actually, for our SLOs. So we can deploy something and we can then validate the requests that are coming in. Are they as fast as I'm expecting on the new deployment, or are they failing, or what's going on? So this is just a little primer. If you want to learn more about all of this, I also have a colleague out there, Henrik, and there's others as well that have great content on observability related topics. But I want to highlight here, Is It Observable? It's a free YouTube channel where Henrik is walking through all different sorts of observability topics in the cloud native space, including OpenTelemetry, DORA, SLOs, Prometheus, and much more. Great. So this was the quick introduction of OpenTelemetry, SLOs, and DORA. Now we go to the three key main topics. I know this is the slide that you didn't see earlier because the sharing was paused for a while, but three areas. We cover DORA, I'll show you SLOs, and I'll show you what else we can do with observability data. I want to start with the first challenge. And the challenge that I've seen is as platform teams are building platforms, right? There's typically, or often in large organizations, multiple tools on top that try to make changes, that try to deploy. You may still have Jenkins in the organization, you may have Argo, you may have Flux, you may have GitLab, you have GitHub, whatever it is. You also may have infrastructure tools, infrastructure as code tools like Crossplane, Terraform, Ansible that make changes. And so the question is really hard to figure out what is actually changed, which changes belong together, what impact does one change have on the other components that are part of this logical app. Because Kubernetes, unfortunately, itself doesn't have a concept of an application that contains or is contained or kind of made up of multiple components. This is now where Keptn comes in. Keptn is the CNCF project I am the DevRel for. We've been around for a while. And what Keptn does, it is bringing application-aware change traceability into Kubernetes. That means as multiple tools make changes or ask Kubernetes to deploy changes, to deploy a new ingress, to upgrade a version of a pod to a different image, Keptn is able to trace all these changes, but is also looking at metadata on these deployments to find out which particular changes belong to which business applications. You can see it here visualized. You can really define what components belong together just based on metadata. And therefore, Keptn is not only able to detect this, but it's also using OpenTelemetry, what I've showed you earlier, to create traces that show you how long it actually takes to deploy all these changes. And it's automatically then giving you the metrics that I mentioned earlier. So technically, just a little technical insight. If you have, let's say, a simple app with 3 components, a front end, a back end, and storage. What Keptn technically does, if you install it on your Kubernetes cluster, Keptn leverages Kubernetes webhooks, and we're extending the Kubernetes pod scheduler. Why do we do this? Every time Kubernetes is trying to then deploy your changes, we get a hook where we can see before the actual deployment happens from the pod scheduler and after the deployment is finished, which means we can actually measure the time it takes for every individual component that gets deployed. And therefore, we can expose this through metrics and traces so that you can look at these information, like how often do you deploy in your observability tool. Now we're doing one more thing, because I talked about the application awareness. We understand by looking at metadata on these CRDs, on these Kubernetes resource definitions. We are looking at metadata and therefore figure out, hey, frontend and backend and storage actually belong to a logical application. That means if you make one change to one component, or if multiple tools make changes to all 3 components, we understand these changes all belong to a certain app. And therefore, we also measure the time from the first change request until the last change request of an application version. And we also, again, create traces and we create metrics. So you can say how often was an application changed? How long did it take? How long did the individual components take? Which of them took longer? Which of them failed? And all of this is available simply by installing Keptn Lifecycle Toolkit on your Kubernetes cluster and enabling it, and then you automatically get your OpenTelemetry traces and metrics. Now, enough with the words. Let me show you what this is. So what I have here is, first of all, I want to show you quickly my console, because I also told you that I will show you a little bit of console, hopefully not to frighten you, a terminal window. Right, make it a little bigger. So what I have here is I have a K3S cluster. This is part of the demo that I mentioned earlier. You can see my namespaces. And if you look at kubectl, get pods in the namespace, Keptn Lifecycle Toolkit. So by default, Keptn gets installed here, right? You can see here that we have a couple of components. Important is the lifecycle operator. That's the operator that is basically extending then through a scheduler, your pod scheduler. Then we also have a component called the metrics operator. I'll come to this in a second. I've also installed OpenTelemetry here. So I have an OpenTelemetry collector that Keptn is then using to send the traces to. I also have Jaeger installed here and other stuff. What else? Argo, observability, monitoring, some other tools that I've installed, like Grafana is installed and stuff like this. So this is just a very, my Kubernetes cluster. Now, what I have on my Kubernetes cluster, as I mentioned, I have Argo. I have Argo here, as you can see. Argo is connected to my Git repository. This is a clone of this demo repository, or a fork of this demo repository that I sent earlier in the chat. And really the important folder here is the so-called simple node dev folder. This is the sample app that I have. And I just want to show you what it takes. So I installed Keptn. If you want to install Keptn, you also have just a chance to go to our website, keptn.sh. Brings you to Lifecycle Keptn, and you can figure out how you get all the downloads, your Helm charts, or also your manifests, however you want to install it. All right, let me go back to my demo. The only thing I need to do is on the Kubernetes cluster install Keptn operator. Then by default, the Keptn operator doesn't do anything unless you are annotating your namespace with Keptn Lifecycle Toolkit enabled. From this point on, the operator will expand and extend the Kubernetes pod scheduler. And what will it do? It will look for any type of deployment changes. So if I have here my deployment, so this is a simple app that I have. It's a deployment, right? It's a very, just a regular, we're latching on to the default CRDs in Kubernetes. I have a deployment, simple node app. I have a couple of things here. So this is where we're looking at labels like app. So we know that this component belongs to an app that is also called simple node. Remember my example earlier, I had an application where we had 3 deployments, front-end, back-end, storage. This is the same thing. I basically have a simple node service, and this one belongs to this app. So if I would have multiple deployments with the same app label, we would automatically detect this. Now, what I want to do now is I want to actually edit this, and I want to change my version. I want to deploy version number 3. So what you see here is I'm changing the version label, and I'm also changing the image. So I'm telling, this is just, these are the standard Kubernetes labels and annotations, and Keptn is just understanding them. So I commit this, and I say upgrade to version 302, I think that's what it's called, commit the changes. So this repo is managed and analyzed by my Argo instance. And I think now what should happen is if I refresh, let's see, it should say it's syncing. Here we go, it's processing. This is deployment V202 that I did earlier. Let's see. It should hopefully soon figure out that there's a change, and it then should deploy my new version. I think it's just coming in. So let's see, there's like version number 3 coming in now. Here we go. This is my new version that currently gets deployed. Perfect. That's 302 is currently getting deployed by Argo. Now, what's happening behind the scenes? Because this is nothing magic, right? This is stuff that you already had. But what you automatically get is Keptn automatically creates traces as Kubernetes is now making these deployment changes, is upgrading my pod. And what we get here is I go to my Grafana. Right, if I look at this, let's go into the last, let's say, 3 hours, right? I can see now that in the last 3 hours, I had a couple of deployments. Actually, my deployment from this last version just finished, and it's still ongoing, active deployment. So these metrics here, I automatically get from Keptn telling me how many deployments I have, how many active deployments are currently going on, how many have failed, what's the average time between deployments, what's the average deployment time, so how long does it take? And for every deployment itself, right, if I look at some of these here, the traces that I had, let me look at this trace here. I just have an OpenTelemetry trace. And here I'm using the Jaeger extension in Grafana. So here I'm now seeing an end-to-end trace, not of the performance of my app, but actually of the deployment. Because if I'm a platform engineer and I want to make my platform available for people to deploy through the platform, then I want to know if things are slow or failing, why it is slow, why is it failing. And here we give you an end-to-end trace of when everything that happened as Kubernetes was deploying these changes. The real interesting thing here is that's the deployment of this particular version, right? This was the workload. There's a couple of things that happened before and after. You can see here app pre-deployment, app post-deployment. This is where I will show in the second demo what we can additionally have Keptn do as part of a pre-deployment and post-deployment validation to validate if a deployment is not only successful from, remember my slides earlier, pod healthy, but also application ready. But point is, we're automatically getting key metrics about how many deployments are happening, right? Obviously per application, I only have my simple node here, but you would automatically get key DORA metrics by just installing the Keptn Lifecycle Toolkit, because we are extending the Kubernetes pod scheduler and giving you these metrics on a workload level, but also on an application level, because we can detect which individual components belong to an application. All right, perfect. So this was the first thing that I wanted to show you. Quickly go back to the slides. The second thing that I want to highlight here is if you're building a platform, then you have the choice to do your, let's say, pre and post deployment checks, meaning execute your tests, validate that your components are all secure by running security scans. You can validate, or after the deployment, you can execute the validation if the pod is not only ready, but also if you can ping it from the outside to make sure that the application is ready. You can build all of this into your pipeline tools, great tools. But the thing is, in large organizations, if you have different tools that make changes, then you need to build these checks into every single tool, into every single pipeline, which is possible, but it's a lot of additional and duplicated effort. And there's also a risk that somebody is just not adding this particular check in the pipeline. So the solution to this is we already have the Keptn Lifecycle Operator, what I showed you earlier, that is monitoring and tracing the deployments. But what we can now also do is we can let the operator also execute pre and post deployment checks. For instance, to execute validation checks if the environment is actually healthy before the deployment happens. If there was a security scan on that image that is now getting deployed. If the downstream systems are available. If that's all green, then it basically lets the Kubernetes deploy the pod. And after the pod deploys, we can also run post-deployment checks, like we can execute additional tests and validations. Technically, how this works, if you think and remember what I showed earlier, we had this pre and post-deployment kind of lifecycle spans that we used earlier to create traces and metrics. Now we allow you, as I mentioned, to also execute tasks and so-called evaluations. So we allow you to execute pre-deployment tasks and post-deployment tasks and pre-deployment evaluations and post-deployment evaluations based on metrics. So technically, again, we go back to a demo. Very easy. The only thing I need to do is, if I go to my simple node deployment again, if I scroll down, what you see here under annotations, there's a couple of Keptn specific annotations. Pre-deployment evaluation, pre-deployment task, post-deployment evaluation, post-deployment task. And there's tasks and evaluations. I want to first show you the tasks and then the evaluations. Very simple. What is a task? If I go up to my other folder, in the sample directory, you will find the Keptn task YAML. And the Keptn task YAML basically allows me to do three things. I can either specify JavaScript code or TypeScript code that should be executed, Python, or I can also define my own container, similar like a GitHub action, where we basically then just run your container as a Kubernetes job. So we either, again, run your container, you can specify Python or TypeScript. These two we would run in a lightweight runtime for you. And then in my case here, I'm using JavaScript or TypeScript, and I can execute any type of code that gets now executed pre and post deployment. My example here is basically crafting a Slack message that I then send to my Slack endpoint. That means before the deployment and after the deployment, I should now get a notification. And let's figure out if this is real. As you can see here, I'm here in my Slack, and I got my version 3 pre and post deployment just sent to me. That means I do these things natively in Kubernetes. I have Keptn execute these checks, and I don't need to rely on a pipeline that is doing this. Right? And the evaluations, I want to show you this as well. It's called Keptn evaluations. Here, I can specify that I want to do checks either pre or post deployment. And you can see here, it's called available CPUs. So my evaluation definition here is called evaluate dependency. This is the one that I specified for the pre-deployment. And I said, before I deploy, I want to make sure that I have enough CPUs. Should be at least 4. I can also do here checks like, is the downstream system able to handle model? Do we have everything set up correctly, right? You can do basically environment health checks. And after the deployment, I have a Keptn evaluation definition for evaluate deployment. Here, again, I validate. We still have enough CPUs, everything is good, but I'm also interested in the availability. So is my system still available? And in this case, I want to make sure my system is still available, 90%. Now, where does this data come from? I'll show you as well, because this is kind of a key component of Keptn. We have a so-called Keptn metric server that allows you to specify different data sources. I have, on one case here, a so-called Keptn metrics provider for Prometheus, where I specify where my Prometheus server is. I also have, because this is what I see in many organizations, multiple observability tools. Like for instance, I have Dynatrace here, and I can also specify some of my metrics come from this particular Dynatrace instance. And now I can specify, as I have my providers, I can also specify Keptn metrics. So I have a Keptn metric here where I say available CPUs comes from Prometheus, and here is the PromQL. But availability SLO comes from Dynatrace, because Dynatrace is doing my availability and real user monitoring. So we define the metrics, and they can now be used as a pre and a post evaluation. And this is also, if I go back to my Argo, right, because Argo gives me a great overview of the deployment that happened earlier. Let me just quickly refresh to see if my version 3 is all good, right? So you can see here pre-notify, pre-evaluation, post-evaluation. If I click on post-evaluation, I also get to see here on that CRD that Keptn truly validated my SLO. It succeeded because Dynatrace told me my system is 100% available in the evaluated time frame, and therefore it meets the objective. Plus, my available CPUs that comes from Prometheus is also succeeded because the value 8 came back, and I expected at least 4 available CPUs. So these are not checks that are happening. If those checks fail, pre-deployment, we would actually stop Kubernetes from deploying. We mark that deployment is not good. We don't let the deployment even happen. Post-deployment, we can then notify you that something is not wrong, and you could then execute tasks that, maybe roll back or, expand your Kubernetes cluster, add more resources. So this is what this is all about. All right, good. I got one more quick use case, but actually, I think we already covered this. But one of the things we also solve with this metric capability I just showed you, where we can pull in metrics from external sources, is a challenge that many of you probably have. If you have not one, but multiple observability tools, and you have multiple tools within Kubernetes that try to use observability data to make an automated decision, like Kata for scaling, HBA for scaling, Flagger and Argo rollouts before rolling out, and also Keptn for the evaluation, then you have to build a lot of point-to-point integration tools. Keptn brings the Keptn metric server. This is a component that you can also install just standalone. That is providing integrations with all these different tools. You can also build your own Keptn data source, or we call it the metric provider, to pull data back into Kubernetes to give the data to all the tools that need the metrics through Prometheus and also through the Kubernetes metrics API. So gone are the days where you have to maintain point-to-point integrations, which just bring the metrics back into Keptn, into Kubernetes. Right, and I think I just showed you how this already works. We talked about this already, so there's no more need for a third demo here, because I also want to make sure we do have enough time for questions that may come in. Before we go to the questions, just to wrap up, we have a lot of different use cases that I think we all need to think about as we want to measure and make sure that the platforms we're building are successful. We need to give insights into DORA metrics. Now, you can calculate your DORA metrics yourself from the pipelines, but what I showed you today is a native way, a Kubernetes native way, to not only get DORA metrics from Kubernetes pod schedule itself. I also showed you how we actually understand how multiple workloads belong together to an app. So we give you app-specific the deployment metrics. We also give you the traces, so you can actually see why did the deployment fail, why did it take so long, and in which sequence were they deployed. This was one thing. Then we talked about adding SLOs as an additional check to your pre and post deployments, right? Because pod healthy doesn't mean application healthy. This is where you need to execute and validate your metrics. Also, the same thing allows you to add automatic tests to your deployments, but we can do it natively in Kubernetes with these pre and post deployment tasks and evaluations. And last thing, we talked about this metric server, right? The metric server is also great to just bring data back from your Splunk, from your Datadog, your Relic, from your Dynatrace, back into Kubernetes to the tools that need it natively in Kubernetes. All right. So to learn more things or try it out, remember, this is the Is It Observable channel from Henrik, where you can learn more about observability. He's doing a great job in covering these topics. If you're interested in Keptn, the component that I just showed you today, get to the website, and the demo here, again, is also available. And with this, I think I am ready for Q&A, and a little over 30 minutes, but I think it took a minute or two before we got started. So I think about the 30-minute mark should be all right.
You are on time. Thank you so much, Andy, for a very structured presentation. I'm sure that a lot of people enjoyed it, and I already see 5 questions on Zoom and some on YouTube. So let's get started. Keptn replace our hotel application collector like a sidecar on service mesh solutions?
No, we are not replacing it. So what we're doing, we're leveraging OpenTelemetry, because Keptn itself, and if I go back, I wasn't clear enough. Keptn itself, if I go to my cluster again, right? When I installed my Keptn demo, my demo installed the regular OpenTelemetry collector. The reason why I installed the OpenTelemetry collector is because Keptn itself, the lifecycle operator, is emitting OpenTelemetry traces that you need to send to a collector to then send it to your observability platform. So it doesn't replace it, but Keptn itself is creating OpenTelemetry traces, it's creating metrics, and it's also creating logs. And we're using just the OpenTelemetry standard for this, so that you can then take this data and, like I did in my example, right, visualize it in whatever observability platform you have. And besides creating metrics for your deployments, as I said, we're creating traces. These are these end-to-end traces that are showing me when a deployment happened and how long it took for the whole deployment to happen, including the pre-deployment tasks and the post-deployment tasks and the individual deployment changes that Kubernetes did for you. So hopefully this made it a little clearer.
Cool. Thank you for the answer.
Yeah.
Is Keptn comparable with other open source or commercial solutions that you know?
That's a good question. I think what we did, so Keptn has been around for a while, and this is also, if you look at some of the older material, Keptn, we call it now version 1, V1, had a workflow engine. It had its own UI. It actually had its own database. And what we got from a feedback, they said, hey, you know, why Keptn is great, but it's doing too many things. We should rather focus on things where we're really good in and leave other things to other tools. For instance, for workflows, use Argo workflows. For a UI to visualize your metrics, you already have your observability platform. Also, we don't want to store our own observability data in our own database, what we did before. This is why we now went to OpenTelemetry, so you can then store it in your observability platform of choice. And so this is for what we're doing right now, like we're extending the Kubernetes pod scheduler to get these pre and post deployment hooks that Kubernetes gives us to actually then do the measurement, do the tracing, but also execute these tasks and even have the ability to let deployments fail. This is something I'm not aware that anybody else is doing, but honestly, I don't know every project by heart out there. Maybe somebody else is doing something similar. Last word on this, basically if you think about it, you could write, if you have a complex app and you want to do pre and post deployment things where you need to do upgrades and checks, you could write your own Kubernetes operator. The question is, do you want to write your Kubernetes operator yourself, or do you want to use also Keptn for a framework that allows you to, through code and configuration, specify what should happen pre and post deployment, and you automatically get also the observability into the deployment itself. So see Keptn Lifecycle Toolkit here, almost like a very easy way for you to build stuff that you would normally build into your own native Kubernetes operator, but we make it very easy for you.
Nice. Yes, there are a lot of tools in the CNCF ones.
Yeah, true. Yeah.
How Keptn tracks if there is an incoming
deploy? Yeah. So they let me just go back to one of the slides that I had. This one here. But I'm actually this one here. I think this is better. So remember, what we are doing is the Kubernetes operator is leveraging Kubernetes webhooks. And for those namespaces where you are putting the annotation on that you want Keptn to monitor it, we are actually then extending the Kubernetes pod scheduler. So Kubernetes pod scheduler has an extension mechanism, and we are using this. And so we hook into the core component of Kubernetes that is taking the request from any external tool to then deploy, let's say, a new workload. And Kubernetes itself gives us this extension mechanism. So this is how we figure out what is deployed. And this is the beauty of this, because we don't need to build an integration with Jenkins, Argo, or Flux to make Keptn aware of it. We are made aware of a request for a change from the Kubernetes pod scheduler. We extend it to say, before we allow Kubernetes pod scheduler to even figure out where to deploy a pod, we can already do things. Right? We can do checks, or we just measure the timestamp when it starts. Then we let Kubernetes do its job to find the right spot, deploy the container. And once it's done, the pod scheduler gives us the opportunity to act on the post deployment. And there is where we can, what I did in my case, send a message to Slack, or I see some other, I think somebody mentioned Slack SDK, incident management. You could do also there sending, creating a Jira ticket, creating a ServiceNow ticket, whatever you want. That's also possible. You can code this because I showed you, we give you different runtime options, JavaScript, Python, and we also give you just a container similar to GitHub Actions.
Well, I think you already answered the other question that I had in mind regarding the Slack integration and Slack SDK. So let's move forward to the next one. How Keptn calculates resiliency metrics of DORA, MTTR, and change failure rate. Is there any integration with incident management tools?
Yeah, so we do not calculate MTTR because we can't, because that's what we don't know, right? This is where I think a professional observability platform comes in, right? Because you deploy and then maybe something fails and then it takes a while. So right now we have not natively in Keptn, we don't know if something fails and how long it takes for that particular problem to be solved. This is where you would use, for instance, a tool like Dynatrace to then find the problem, the root cause, trigger an incident, and then once this is done and the problem is resolved, then you get your MTTR from those tools. What we do, however, is the change failure rate, right? Because remember here, when you make a deployment, let's say to the front end, and let me go to the next slide here, right? If you make a deployment change to the front end, Keptn will see, okay, front end changed, which means I am now executing the tasks post-deployment, right? Let's say running a test, maybe you make a curl statement to validate that the new app is also still available, run some synthetic tests, and then you can also evaluate. So in case something fails here, we know that while the pod might be healthy from a Kubernetes perspective, your post-deployment tasks and evaluations were not successful. And therefore, we can report these are not successful, and therefore we have to kind of the change failure rate. But what we don't have is the MTTR, the mean time to resolve. Maybe we'll figure out a way later on to do this, but that's what we don't do right now. And I think we rather see this with incident management tools and like observability platforms and incident management tools that then track the whole process.
Nice. Where is the data hosted? Is it all in Kubernetes cluster, or like it's not on Keptn servers?
No, I mean, the beauty is, right, we're using OpenTelemetry. I mean, wherever you send your OpenTelemetry data to. If you don't know OpenTelemetry, then I can again point you to some of the videos that Henrik has been doing. He's doing a great job on explaining OpenTelemetry, but basically Keptn is just creating the metrics and traces and logs, and then this data gets sent to the observability platform. We are creating observability data. We don't store it. We create it, give it to OpenTelemetry, and then you send it to wherever you want. Yeah.
And then another question is, can Keptn be used not in the Kubernetes context?
Can Keptn be used not in Kubernetes context? So Keptn itself runs on Kubernetes, full stop. And that's what it is. Yeah, it's a cloud native tool. Now we do have the version 1 that I mentioned earlier. The version 1 also runs on Kubernetes, but it has a couple of capabilities where you can also, it's used it was used and is still used by some to execute validations against external data sources. But Keptn itself, the version 1 and what I showed you today, what we call now the lifecycle toolkit, requires Kubernetes to run.
David, I see your question regarding forcing Kubernetes adding the functionality, but Andy, do you remember which functionality you're referring to? Maybe let's table the question until you clarify. Because
where's the question? Is it in the chat?
It's
in the chat.
Yeah.
Do you foresee adding this functionality to cases and it's expanding? That's a good point. We are working in different special interest groups. For instance, the whole app definition, because the Keptn detects apps based on certain metadata. We want to have a standard there. We also, I think somebody said earlier something about OpenSLO and cloud native events. We obviously want to make sure that we understand all of these standards. Yeah, but maybe some of these things will make it into Kubernetes native at some point, into the core components. We'll see. I don't know. Yeah.
Cool. Yeah, that's what I meant. Thanks. Cool. Another question. Keptn demo today focused on telemetry generation application, but can I use it also to do pre-deployment security functions? Is there any plans to add webhook tasks on schedule interval to collect metrics for when running reports?
So I want to ask, first of all, you can do pre-deployment security checks, because you can do, if you remember again, right? If I go back to my demo, these Keptn tasks, going not too far, simple note. These Keptn tasks allow you to write your own JavaScript code or Python, or you can just specify a container that we then execute and run as a Kubernetes job. And then you can, that job can do a security scan, whatever, right? Because you also get this context data here. So your task pre or post deployment gets the context for which it was, for what it was actually executed. Yeah. So you could do this there. So this would be the first question. But the second thing, and I think you just deleted this. I don't see it anymore. There was the long running thing. Again, we are not an observability tool. We are using observability data and we are creating observability data. But if you want to have long running checks, this is something where you want to use, send your observability data to somewhere and use the mechanisms. Like, again, I work for Dynatrace during the day. We have a powerful observability platform, and we do automated validation continuously on all millions of data points, and we have an AI that detects anomalies. These tools, whether it's Dynatrace, Datadog, New Relic, all of them, Honeycomb, right? You can name them all. They should be used for something like this. They should be used to validate long-term if your system is healthy or not. What we are doing here is we're focusing on the delivery aspect, bringing you observability into your deployments, and adding things like pre and post deployment checks, because this belongs to deploying. But once you release something, then you want to have a system that is continuously monitoring it and continuously giving you feedback in case something fails. Even maybe at a later stage, maybe this happens a day later, a failure, or a week later. You don't want, this is not what Keptn is for.
Well, and I assume it also answers the question around current capability to have tasks at pre and post deployments
only. Yeah, you have to. Yeah, of course, you can do that as well. Yeah.
Cool. Are the Keptn tasks restricted to be containers, or can be externalized, assuming you have legacy checks already?
Right now, Keptn tasks will be deployed as a Kubernetes job. And if you're using Python, if you're defining Python or TypeScript like here, we basically deploy the Dino runtime as a container and then map this code into it. So we execute it there. If you give a container, we just run your container as a Kubernetes job. So that means the tasks itself run within Kubernetes. However, right, if you think about tools like, I don't know, Ansible Tower or AWX, the open source version of it, you could use it a task like this that then triggers an Ansible script or an Ansible instance that sits outside of Kubernetes. So that's also possible, obviously. Now, also from this pre and post deployment checks, because somebody says, maybe need to look into Dynatrace and Honeycomb. I mean, I don't want to make a commercial on this here, but also check on what some of these commercial observability tool vendors can do when it comes to workflows, when it comes to executing more things based on data and events. So for instance, I can talk about quickly Dynatrace. We allow you to execute workflows in an enterprise environment inside. I mean, and then we've built a complete workflow engine with retries and with everything that you can then also trigger from an event that Keptn, for instance, emits, or from a particular data point when something is wrong. So check out some of these more complex versions of checks, what other tools can do as well. We want to focus Keptn on what we think we need to do is bring in observability into your deployment, giving you the metrics and allowing you to do pre and post deployment checks that are really, I think, you should focus on deployment itself, not what happens a day or a month later after the deployment.
Cool. Does Keptn have any options to scale on a multi-cluster scenario like Thanos for Prometheus?
So again, if for multi-cluster scenarios, you would install Keptn on every cluster and then enable Keptn on each namespace on the cluster where you want to have it. And then the way we scale is really, we are emitting data. We're emitting it through OpenTelemetry, and then this scales the way OpenTelemetry scales. It means you send your data then to your central observability platform. If the question is, can Keptn trigger? Yeah, I think no, that's my answer. Yeah.
Mm-hmm. Cool. Can Tick also fit into Keptn Lifecycle Toolkit?
Yeah, it can. I mean, we even did a webinar. I did a session with the guys from Tyke already, with Sonia Schäffle. I'm not sure if she's online. We did a session on how this fits together. Yeah.
Cool. So the answer is yes.
Mm-hmm.
Okay, 19 questions answered, and we have 6 minutes till the webinar finishes, runs up to 1 hour. So I'll let you go to enjoy Barcelona. Oh, hold on, one more question. Eduardo and David do not want to let you go.
Okay.
Let's take this one last. Is there any danger of back pressure? How much data is Keptn generating?
There is no. So again, we are generating data, but the back pressure will not be on Keptn. The back pressure would maximum be on the way you set up OpenTelemetry. And believe me, we are generating very minimum data compared as if you're using OpenTelemetry to monitor your business critical apps, where you're monitoring with OpenTelemetry potentially every single request that comes in to your system. And if you follow a little bit on what's happening in OpenTelemetry, it scales pretty well, especially with the collectors and then the backend observability tools. The only thing what you want to be careful with, right, is because if you're leveraging the pre and post deployment tasks, that means Keptn will create and execute containers for you, jobs for you, and you obviously this is just like with everything, you want to make sure that your cluster is also sized for that, and that you can execute these tasks natively in Kubernetes. But as Kubernetes is becoming the platform of choice, it seems, we thought bringing these checks into Kubernetes natively makes a lot of sense, instead of having all of them sit outside in platforms in complex pipelines where you are trying to then call into Kubernetes and do the checks first, and let the Kubernetes deploy, then wait until it's deployed, and then afterwards execute more actions. So we thought bringing some of this complexity into Kubernetes would be a good thing. Yeah. Is there a mechanism to handle errors in those pre-post tasks? Yes. If there's an error in a pre-task, we just tell the Kubernetes pod scheduler to not even deploy, right? It's the same thing. If you're familiar with the pod scheduler, normally the pod scheduler, what it does, you say, I want to deploy this container. Then Kubernetes looks into what are the requirements of this container, how much CPU, how much memory do you need, and then it finds the right spot. If it doesn't find the right spot, it says, you cannot deploy because you don't have enough resources. And basically what we're doing, we're extending this mechanism. That's why we are a Kubernetes pod scheduler extension. We are kind of extending the checks on whether or not this pod can be deployed, but you can now call all of these tasks. And so if a pre-deployment task fails, you will know about it, because we are basically telling Kubernetes not to deploy, and Kubernetes will say cannot deploy container. The beauty of this is, this would then go back, this error, to your deployment tool, your Argo, your Flux, or even your Jenkins. And basically it will say, hey, I couldn't deploy because Kubernetes is not allowing me to deploy, not because I don't have enough memory or CPU, but because my pre-deployment checks failed because my environment maybe wasn't ready, right? And so this is why I think I think it's a very elegant solution. That's what I'm saying. Yeah.
Nice. I think you got some good thought put into the solution itself, and you're getting a lot of compliments on the presentation. So thank you very much. for staying with us here. And guys, I posted the link to the Platform Engineering Slack channel. Andy is a part of the Platform Engineering Slack channel. Just join in. If you have any other questions, I'm sure that if you post them and either ask directly or post them below this presentation, he'll be able to answer today or tomorrow. Also, we'll send over the slides as I promised, and webinar replay to this session tomorrow, so that will be in your inbox. Next week we also have a webinar around developer-centric culture, so you can sign up to that one next week. It will be on Thursday as well. Cultivating developer-centric culture for continuous improvement, more of the how to build teams and foster this good relationship within the team. So hope to see you there. Hope you have a great rest of the day. Andy is gonna go and dance salsa. I will just stay at home. We all have fun yeah, see you next week. And thanks so much, Andy. It was an amazing presentation, and maybe we should do another one.
We should. Happy to do so. Yeah.
Thank you. Bye.
Bye.